Welcome. In this video, we are going to take a look at problem 15. It is from chapter 7 of College Physics 2E by Openstax. In this problem, we need to use energy considerations to calculate the average force that a sprinter exerts backward on a track to accelerate over a specified distance, and there's also a headwind. Okay, let's start with what we know. Okay, we know the mass of the sprinter, and that is 60.0 kilograms. We know the initial velocity, I'll use V naught, is 2.00 meters per second. We know the final velocity is 8.00 meters per second. The distance is 25.0 meters. And then we have a headwind force, I'll say F sub W, of 30 newtons. Okay, and so let's say the sprinter moves this way. Then the sprinter puts a force on the track that's to the left. So the track puts a force on the sprinter that is to the right. So let's call that F sprinter. And then the headwind opposes motion. So let's put our F wind back this way. All right. And so when we sum the forces, we get the MA. But the sum of the forces, just the left-hand side, is going to be Fs minus Fw. Okay. And so now we can use the work energy theorem. Work is equal to the change in kinetic energy. So that means work is 1/2 mv final squared minus 1/2 mv initial squared. All right, we also know that work is equal to the sum of the forces times d times the cosine of the angle between them. In this case, that's going to be 0. So let's put cosine 0. And so that means, or we can also use work is equal to F net times d times the cosine of 0. I'll stick with the first one. And so we're going to get the sum of the forces is the work divided by the distance. All right, so the net force, or the sum of the forces, is going to be the work, which is 1/2 mv squared minus 1/2 mv naught squared all over d. We can factor out the 1/2 m. We will get v squared minus v naught squared over d. And now we might as well substitute the numbers. So we've got 1/2 of m. M is 60 kilograms. And then we're going to multiply by, in parentheses, we're going to have final velocity, so 8 meters per second squared, minus initial velocity, 2.00 meters per second squared. All of that is divided by the distance that change in velocity occurs over, and that is 25.0 meters. I did that calculation and I got 72.0 newtons. So that is the net force. And we have the net force is Fs minus Fw. So Fs is going to be the net force plus the force due to the wind. And so Fs is going to be the 72 newtons plus the force due to the wind, which was the 30 newtons. This gives us a force of 102 newtons. And now we are looking for calculate the average force a sprinter exerts backward. Okay, so the direction is backward. So we found the force on the sprinter due to the track. We need the force by the sprinter on the track. It will have the same magnitude, so it will also be the 102. So we can say, so the sprinter exerts 102 newtons of force on the track, and the direction is backward or left. And that was using Newton's third law. I hope that was helpful. Let me know in the comment section if you have any questions. Thank you for watching, and I'll see you in the next one.